Hello everyone, my name is Thanh Bui. Today I would like to present our research of a multimodal road node detection system for fog computing. So before we start going further with the detail of the research, I would like to introduce with the structure of our presentation. First of all, we will introduce our research motivation, uh, the background knowledge that we use for our research, our proposed methodology, the result from our experiment, and what we find from the experiment. Then we move on to the limitation and our future work for the current research. Let's start with our research motivation. There was a rapid bloom of IoT just within over a decade, from under 1 billion in 2010 to about 10 billion in 2019, and the trend continues going on. In a recent prediction, there's gonna be 31 billion Internet of Things devices by 2025. And why it's become a very potential growth is also come with a potential threat since they are susceptible for the cybersecurity attack. According to the 2020 report of IBM, monetary loss due to this type of threats for the US is the highest among every institution or agency in the world. And the cybersecurity threat is not limited to just technology companies, but also government agency, uh, bank database, any information related to their customer, insurance company, health and healthcare service, in which healthcare service is one of the prime target for those attacks. In the recent year, many IoT device manufacturers start to shift to use the cloud-based computing for more mobility, especially with the new fog computing structure, because it gives a better flexibility, mean user can using their same profile setting in multiple devices. They also increase the number of concurrent user and lower the latency, allows the user to be able to update their information in almost real time. However, this also comes with a potential problem in increase of number of vulnerabilities due to higher access point. So there are many recent research efforts directing to limit the damage of cybersecurity threat on the fog computing system, while most of the research focusing on protecting the system on external threat, internal threats are also costly. According to the Ponemon Institute report in 2018 and 2020, there was a 25% increase on the average cost due to internal attacks. That's including the investigation and the cost to fix the security plot hole within the system. And one of the most imminent threats of internal attack is using the root node within a fog computing system. Basically, the perpetrator will plan one or multiple root node that allows them to access to the system, and those nodes usually have a ever-changing pattern, so that the normal detection system would be very difficult to detect those nodes based on their behavior. To the best of our knowledge, most of the current work in the internal attack threat on fog node computing are based on the c- constructing a trust benchmark between each node within a fog computing system. So basically, they would use an anchor node to detect whether the node surrounding it would be root or non-root. This also having a trouble with negative condition due to different resource requests. So for example, I can request the resource, and usually it will give me permission in a normal circumstance. However, there's some circumstance that I would not be able to access to the certain resources. And advanced text system require maybe some advanced detection system require alternation of the system and may affect with user experience. So our contribution with this is we try to utilize the ABAC or attribute-based access control system to quantify trust value from each attribute of requester. Basically, each requester will have some attribute, and we want to know how trustful those attributes from the requester. And we construct a distance matrix from back-of-word model to separate node into subgroup, which also help us to separate into smaller cluster, and we can investigate them individually. Then we also combine the back of word model and ABAC system to generate attributes trust vector for each node, and we can start apply machine learning classification model to help us detect the root node within the system. Before we start with our proposed methodology, we'll try to mathematically define our element within the system so that we can correctly represent them in terms of mathematics. In here we split the data into three smaller sets where U, O, and D, where U is a set of user, O is a set of all the object that's being requested within the system, and D is what the decision make they are giving out for each request. Uh, each uh, each attribute will have an attribute range V, and we represent the access request as a tuple. Then we also represent the authorization as a tuple based on the access request tuple, where so we're showing like for each request R, we will have a decision D go along with it, and we have the access log node access log for each node N. Then we calculate we have the frequency of the permit decision, like basically is it allowed or is it denied, and we represent it with a positive and negative nodes for easier representation and formulation later on. Uh, we also have the proposed class for each node N. In this case, we only have two classes as a benign and malicious. And then all the benchmarking that we use for to build our machine learning model of detection. For evaluation metrics, we are trying to focus to reduce the misclassification of root node within the system. Hence, false negative rate is what we target, and the key metric is the recall. Other metrics we're also using along is the accuracy, the precision, and F-score. As you can see in here from the confusion matrix that we are focused on the negative prediction value. Why is it important? Because I would rather have quarantine the wrong node as a root node, and we correct it later on instead of like having them running rampage within the system and we have to fix the problem. We're gonna face with a bigger issue. Now we start moving on to the main part of our presentation today. So our proposed procedures for each node, we're gonna collect an access log, and those access log gonna contain the information of all the historical information of like what resource being requested and who's being requested the information of that user and what's the request being accessed or denied. Those access log for each node can be think of as a small database kind of thing. So we try to classify whether this based on the historical database record, this node is trustworthy or not. In order to do that, we split the data into the training set and the testing set, where in the training set, we're gonna use the k-mean clustering, separate them into smaller group where they're gonna have a different model for each cluster. And we also do the feature extraction for all the training node and to know what feature we should be focused on to do the mm, machine learning classification model. We're gonna do the same thing for testing data, but just having the feature extraction and like the what the resources they request, so we can give their put them into respective uh, model used for prediction. And in the end, we would want to be able to predict whether a node is benign or malicious. So perform the clustering task, we use the resource request pattern as the key feature. We're gonna vectorize the resource request frequency for each node, and the length of the node is the cardinality of the set of object request object. So they're gonna be the same link for each node, just like different frequency for different resources. And we perform the k-means clustering on collect information using alpha method to find the optimal number of k. Uh, and we use the code size distance to calculate the proximity between nodes because we want to focus on the resource request characteristic, not the magnitude. To the main point of our research is the feature extraction method. And for each access log node, each value is assigned with a trust value calculated based on historical data from the log they are collected. We try to quantify the trust distribution for each attribute value on each node. So like even the same value gonna be different between each node. And like since the distribution being different, when it becomes significant different, we can see that the characteristic between those be different. And this also varies on the cluster because like as the negativity that we start in the beginning, maybe some user will be more welcome from one cluster but not welcome on a different cluster. And to be able to do that, we use a point system where the attribute value gonna gain 1 point if they was allow access if they associate with a user U, and losing 1 point when the they associate a certain user U on the same cluster on the same node, but like they're getting denied. And after we calculate the total point. We want to normalize by device them over to like how frequent they're being requested on over the just the node, and like it's gonna be calculated all over again for each different node. So there's also problem, for example, if some value is being first time introduced into uh, no, what would we do? So it's gonna be give a score of 0 because score of 0 here is equivalent between access and deny, which is not different from a coin toss decision because it's 50-50. So to test our theoretical method, we perform the experiment using the historical access log of employee provided by Amazon. The dataset is available in Kaggle, and even though it has been like over 10 years, it's very popular for the ABAC model testing due to the how realistic is it. It's just skilled to work more allows access decision. Uh, because surely it's challenging to detect abnormal behavior, and there's also have a large number of records, so it's help us to populate our simulate data easier, uh, and to test to see how effective our methods is. We're gonna test this using we're gonna build different machine learning model detection model such as support vector machine, decision tree, boosting tree, and of course our multimodal method by combine like just the three methods. uh, we just want to use the three methods to see we just using those basic methods can we achieve uh, some desirable performance. And we also performing a grid search with different setting for each model, and with the focus is to on the recall score, like the higher recall score would result in a better model. So we believe that we had do a thorough search to find the best model. So far result and finding, we found that the gradient boosting tree and proposed method have a very similar accuracy score, and but proposed methods had a slight advantage in terms of identifying root node from fog computing system. Support vector machine and decision tree also have a decent accuracy score, but they have a significant lower recall score, which means they are fail to detect many root node. And it's proof that our feature extraction method is somewhat working and being helpful even with a very simple method, and more have a better performance with the state-of-the-art method. So we further dissecting into the cluster level to see how our proposed method perform. We can see that the cluster level number 2 is actually have a very high accuracy but very low recall, which means the road node in the cluster would have a very close distribution or behavior with the real node. So as a system administrator, they will need to have a closer look to identify and probably have some quarantine method with some certain resources due to they highly being affected or contaminated by those perpetrator. Meanwhile, cluster number 4 have one of the lowest accuracy score, but they have a highest recall score, indicate that those tailor model that focusing on certain node would actually work in this case. And as further dissecting into those clusters, we can see that cluster number 2, cluster number 5, and cluster number 7 actually have a lot of resources. In fact, there's the top 25 most frequent request resource for each cluster, and you can see like their graph is much bolder, chunkier than other graph due to they have a high recall score. So there's as a system administration, I would probably focus on those nodes and try to quarantine those resources and do further investigation. It's gonna help me to estimate the damage of system on each cluster, like how badly they're being if infested, and then we can redirect node requests to different resources if needed, and as well quarantine root node from causing more damage. So let's talk about some limitation and possibly future work for our research. One of the problem is initial case value for k-mean clustering is heavily affecting the performance, and you can see a low number of case result in a slower runtime because they have to uh, split into like way smaller, and that the runtime is increasing exponentially. However, the low number of k actually does not give us a distinction between those cluster. So like we probably not gonna see how different between those cluster clearly. Then we also lack of some correlation quantification between value of v. So for example, this some value of v may be highly correlated to other value. For example, let's say engineering may associate with some certain value, and HR gonna be associated with some certain value. So it's may affecting to the outcome. So in our future research, we probably try to have some benchmark to quantify those value, and hopefully it's gonna result in a better performance. And finally, here's our reference for our information that we present in the presentation. So thank you very much for attending the presentation. And for any further information, please contact me via the email as tbui@uark.edu.